So guys, today we are going to discuss a CSES problem, coin combinations 1. So what the question states is we are given n type of coins and we are given a sum of money x, and we have to find the number of ways in which we can make that sum of money. In the by the question itself, by the test case itself, it is very clear that we can use any number of coins, and also the relative ordering do matter. 225 and 252 are two different ways. So let's try to solve this problem using tabulation DP. So guys, what we are doing is here basically we are just taking the input, right? We are just taking the standard input, and we are initially initializing a DP array. So basically, what does the state represent? So what might DP of I represent over here? DP of I represent over here is the number of ways to make the sum I, given I have the coins from given I have the coins and I can use it any number of times, and the relating order do matter. So and then we are initializing the base case at DP of 0 as 1. So what is the basically the like why I initialize it with 1? So again, let's say we have a coin named 2, we have a coin whose value is 2, and we have to make a sum 2, right? So if we can take 2 one time and 0 one time, right? So it will become 0. So this 0 should return 1, right? Because since it is a valid part, so we should return it. Similarly, if let's say we're having 4, so it will again go to 2, then it will go to 0. So again the 0 should return, 2 will return something to this, but this 0 will still because it's a valid path. Because if we are going towards a valid path, and at the end of the valid path we should return a 1, right? It like people think that recursion and tabulation are two different things, but we have done the same thing in the recursion as well. So try to have the analogy between the recursion and tabulation as well, right? They are not two different things. Also, let's see what we have done next. So basically what we have done is that we are we are traveling from 1 to x, right? So we are traveling from 1 to x, right? So why we are traveling from 1 to x, right? So because we need to be sure that our the previous value should be pre-filled. When I am at I, uh, like j less than I should already be pre-filled, so that I do not have any hiccups in calculating the answer for this I, right? So what basically is happening is, let's say I want to make I amount of money, right? So what I will do is, to make I amount of money at the end, I should must have taken something, right? I might take 2, I might take 3, might take 5, if these are the coins given to us, right? So what we can say is, so the number of ways that at the end I would have taken 2 would be same as DP of I minus 2, right? And what is 2 here? 2 here is the array of j. And if our array is 2 3 5, this is array of 0, this is array of 1, this is array of 2. So it would be dp of I minus array of j modulo mod, right? So this is our solution to this. So I hope guys it is clear, because we are doing these things in the past 3 questions, right? I hope you would have understand it, right? Because now it's really the same thing which we are doing over and over again. And now also I would like to focus on the time complexity and the space complexity. So starting with the space complexity first, it would be order of x. And also one more thing guys, generally in the recursion there is a recursion stack complexity as well, recursion stack complexity. So that is also recursion space, basically the space complexity to store, like to all the to, because the compiler also have to store that, right? Like what are the calls happening and all that stuff, right? So the complexity for that as well in the recursion adds up to O of x again, right? Because the number of states, right? And so here it is only O of x. There it we can say that we have saved 50% as compared to recursion over here. So it is only O of x here, and the time complexity is x into n over here. I hope guys that you would have understood this question. Now let's try to submit this code, right? Okay guys, so our solution is accepted. See you in the next video.